These two are the AIPMT questions from Doppler effect of chapter waves. Let us solve them. The first question says, a source of sound emitting waves of frequency 100 Hz, this one, and an observer O is located at some distance from each other, here. The source is moving with a speed 19.4 at an angle of 60 degree. Angle is given for us. The observer is at rest. What is the apparent frequency heard by the observer is, right? So, to solve this question, we shall know the equation for the apparent frequency. There is a change in the frequency, the relative frequency, the apparent change in the frequency heard by the observer when source and observer has a relative motion is called Doppler effect. That apparent frequency can be calculated as this formula, where VO is the velocity of the observer. But it is given that observer is at rest, so this VO becomes 0. So n dash equal to V plus or minus 0 by V plus or minus Vs into n, where V is the velocity of the sound. Now, I have tried V plus or V minus is the question, right? But if you look at the source, is moving with an angle to the observer. So, entire velocity of the sound source is not towards the observer, which can resolve into components. This becomes adjacent component Vs cos theta. This becomes Vs sin theta. If you notice, this Vs sin theta has no relativity towards the observer because that's altogether going in a perpendicular direction. So in this case, velocity of the source means only velocity of the source cos theta has to be taken into consideration, and that is approaching the observer. As it is approaching the observer, apparent frequency increases because of the motion of the source. So V by V, I have to write as it is approaching, apparent frequency increases. So n dash is more than n. For that to happen, denominator has to be less. So V minus, not the entire Vs, only Vs cos theta into n has to be taken into count. So V value is given as 330. 330 minus velocity of the source is given for you in the problem as 19.4 and cos 60 into apparent frequency is 100. So this is 330 by 330 minus 19.4 cos 60 is half of 100. So this is 330 by 330 minus 2 9s are 18, then 14 is there, 0.7 and 100 is there. So 330 by 320.3 of 100. So it must be definitely more than 100. So 197 can be definitely ruled out. When you calculate, you will get 103.2, something like that. So it's approximately 103 Hz. So 103 Hz is the right answer for the problem. That's how we apply Doppler effect to the first problem. Let's apply the same to the second problem. Let's have a look at the second problem. It says, a car is moving towards the high cliff. So imagine a car moving towards a high cliff. Imagine this is the cliff. The car driver sounds a horn with a frequency F. So this is the source itself who is making sound. The reflected sound heard by the driver has a frequency 2F. So what's happening is this sound is going towards the cliff and then reflected back. And who is hearing it? The driver himself is hearing it. That means the car driver himself is the source and the observer itself. But what is the source that we are hearing is the reflected sound from the cliff. The driver has a if the what he has given, the driver has heard a frequency, that means it's not the original frequency, he heard it like so. That means it's an operant frequency. So I can write a formula. Operant frequency of a Doppler effect is V plus R minus Vs by, V plus R minus Vo by V plus R minus Vs into N. So when I have to write a plus and when I have to write a minus, let me understand, right? Here, the observer, this is the car driver, he himself is the observer, is approaching the source. This observer is approaching this source of sound that is coming towards him. So operant frequency increases, thus numerator has to increase. Now the source, that is reflected sound, is also approaching the observer, right? So as the source is approaching, because of the source also frequency has to increase. As that is in denominator, if it has to increase, I have to write a minus. That's the equation for the apparent frequency. That implies N dash equal to, both Vo and Vs are same. I call that as X because it's the same driver who is moving of the car. But it is given that this N dash is twice the frequency of the original frequency, 2n. So 2n equal to V plus X by V minus X of n, or F also I can write. Both of them can be cancelled by cross multiplying. 2v minus 2x equal to V plus X. 2v minus V equal to 3x. That implies X equal to V by 3. So the velocity of the car, that is both observer and source, has to be 1/3 of the velocity of the sound. That's how we have to solve the problems of Doppler effect. So the most important formula of the Doppler effect is this formula. So you have to understand carefully when I have to write a plus and when I have to write a minus, right? I have done a detailed video derivation, so you can go through and understand it in detail, that how we are getting that formula and how can we use that formula. That's it. Thank you for watching.